I'm now recording. Welcome to Python 1. This is going to be my last lecture for a couple weeks, but Eustace is going to pick up after this lecture and do the rest of Python with you. But in the meantime, we've got a bunch of cool stuff to do today. So as I said, welcome to Python 1. And our objectives for today are going to be a couple of things. We're going to figure out what Python is, what is Pythonic code, what's the difference. We're going to talk about setup and how to do that on a very quick basis. If you need more in-depth like troubleshooting or anything, go to office hours. They'll be able to help you out there. In terms of content, though, we're going to be talking about print statements, variables, conditionals, loops, functions, lists, and exception handling all in one. It's going to be a really packed lecture, but I think we'll be able to make it through time-wise. So that being said, what is Python? It's a programming language. The end. We're done, right? No. So unfortunately, it isn't just that. We do have a little bit more to talk about, and we're going to start with the fact that it's an interpreted, object-oriented, high-level programming language with dynamic semantics. It's a tongue twister, I know. Basically what that means is that Python is a language that is interpreted just like Bash, but it's also object-oriented and has high-level programming languages, or is a high-level programming language, which means it's easier to write in than, say, C or C++. So Python is really great for some things, and that's why we're teaching it, especially because it has a lot of different uses in industry. So interpretive languages are run by an interpreter when the language when it reads the code line by line. And so we talked about that a little bit with Bash. The idea is that it runs each line as if it hasn't seen any of the rest of the code, which leads to some interesting performance and like behaviors. And so it's not just interpreted, it does compile first, but it's a little bit of a weird, finicky process. So don't pay attention too much to that, but it's just something that you might want to know. So Python files have the py extension, which basically means that it's a Python file. So what is Python? It's object-oriented, right? And that basically means that it's centered around the idea of using objects instead of functional programming. Well, functional programming is one option, but basically the idea, imperative programming is the word I'm looking for, where you just say, okay, set a variable, use that variable, and so on, just in main function, you don't touch anything else. Python is object-oriented, which means that you can create objects and modify them, and it allows you to store data in a much more fluid way. So objects are abstract data types, and yeah, I already said the rest of this. So it's a high-level programming language and a language with strong abstraction from the lower-level aspect of the computer. And the way I would put this in a more human way is that basically Python makes it so that you can type almost English and it will just compile and work for you. You don't have to worry about anything complex or something that's going to worry you. So that's what's really nice about Python. What is Pythonic code? So Pythonic code is this really interesting idea that's sort of unique to the Python community, and that is that Pythonic code is a design choice where you're creating highly readable Python code, but in a way that is very unique to Python. And so poorly styled code can still do everything else that Pythonic code can. It's just that it makes it much harder to read and it makes it much less easy to debug. So in order to sort of do something as a developer in the real world, Pythonic code is really where it's at because you're going to be able to fix things a lot more quickly. And so a good rule of thumb for Python is if you can write less while you're maintaining that readability, do that. So if I can write something that takes like 5 lines in 2 lines, but I can still understand what's going on, then I should be doing that. And that's the idea behind Pythonic code. And so here are some good examples of it. I'm going to open up this link here. And so you can read through this on your own, but like, for example, instead of doing these 2 lines where it's kind of hard to read, you just say make a complex and then you return it with those kinds of parameters. And there are a bunch of other examples here. You can take a look through them on your own time. I will have the links in the lecture slides. So, super quick setup info. You can click these links. Basically, all you'll have to do is download a file and then install it. And it depends on what system you're running. But once you get it set up, then all you have to do is go to, say, your desktop or repository or wherever, and then create a file. So in this case, I'm going to do test.py. And then we'll get back to that in 1 second. I'm putting the cart before the horse. So the other thing you can do is you can use an online editor like Replit, and we'll do that for the rest of the lecture. But let's show how to do a local Python program just to make sure that your environment is set up. So as I said, right, we're going to be creating a Python program, in this case just hello world. And it's a great way to check if your environment is set up correctly and you have everything installed. And so in order to do that, we're going to create that Python file that I was just talking about. So in this case, here we go. And now what we're going to do is we're going to put in print hello world. And we're done. Pretty simple. You guys all remember Vim, hopefully. So I just saved it to my desktop. And now if I type in python3 test.py, this is going to run it. So what this is saying is there's a Python 3 file, and we are going, this is Python 3, so we're going to use Python 3 to run it. If you're on Windows, you might be able to get away with just saying Python, but on macOS, because Python 2 ships with macOS, you need to be using Python 3. Point being, though, you say, I want to use Python, and I want to run this file. And when you hit enter, there you go. We now have hello world. Python also has a really cool thing where you can open up an interpreter, and now we can do things like print hello world directly from the command line as if it were our as if we were using bash for the command line in a way. So that's Python on your local machine. It's not too hard. And so let's go forward a couple slides here. So let's talk about variables, okay? So variables, to do a recap from bash, are a way to help us store stuff in programs. And the reason I say stuff there is because we can store more than just data. Python is a way, or Python has variables that store more than just simple data and numbers and that kind of thing. Like you can use variables to store all kinds of different things using Python. So yeah, a good way to think of it is that there's a box that you can put things in, and it can be like a number, a string, or a reference to another variable as opposed to the data inside that variable. You can do all kinds of cool stuff with Python variables. And what's really nice about Python is that you don't have to specify a type when you declare a variable. And that means that you can get away with saying, hey, this is a string, without having to say, like string variable name is equal to, and then making a string, right? And this is what's known as dynamic typing. Python just kind of figures it out as it's going along. And so different data types that you can use are integers, floats, strings, booleans. You've probably all heard of these before. If you haven't, integers are just a integer as you would know in math. A float is a decimal number. A string stores a bunch of characters, and then a boolean is true false. So variables also can be none. None is a really interesting thing, and this is where that layering of abstraction comes in from before. So none is technically 0, false, or an empty string, right? But in reality, it's its own type, and the reason that is if you have a variable but you don't want to have anything in that variable, you can set it to none and then check for it later on. So none is a really cool idea to sort of have a placeholder for a variable until you need it ready. And so a really good use of it is just as that box to keep things until you're ready to actually fill it. And so none is also somewhat equivalent to null. I won't get into the differences, but they're essentially, for the purposes of this lecture, the same. So here is an example of some code. And so you see here we say x equal to 4, and then we give a bunch of different numbers. and then we give it I'm a chameleon, and then we say print X. So in Twitch chat, let me know if you have any ideas what this is going to print out. All right, cool. So yeah, it looks like everyone's getting it. It is I'm a chameleon. And that's going back to that idea of dynamic typing and being able to set variables dynamically. So in this case, we started off by saying X is an integer, then we say X is an array of integers, and then we say it's a string. And as a result, we kind of get that changing that's going on so that in the end, X is being printed out as I'm a chameleon. All right, perfect. So let's talk about conditionals. So conditionals are a way of using control flow in your code. So it's known as if or else, right? And so it's an incredibly powerful way for you to control what code is run at any one time. And the way you do that is by using these operators down here. So you could say if one thing is equal to another, if one thing is not equal to another, if they're greater than, less than, greater than or equal to, less than or equal to, or if I go forward, there we go. Or if it is, so for example, if we said if X is none, that would check if X is of type none. And then in, that's checking if like a variable is in a list or an array. So here's an example of some code. And so in here, we're defining X as an input that we get from the terminal. And then we're using if else. So let's talk again in Twitch chat. Put your answer. What do you think is going to be printed out here? Yeah, this is Python 3. So does anyone have any guesses on the conditional statement? Oh, I probably should have mentioned this. The input would be, say, 196. So if I open up the code here, let me do that real quick. We're going to see the code, and now if I run it, now it'll say what number it is. So if I type in 196, let's see if this helps. What does everyone think it's going to be now when I hit enter? All right. Well, in case the title didn't tell you, you're probably wrong if you entered we have my favorite number. And so this is really interesting. This is a trap. It's a very trick question, and it is purposely written in a way that was probably going to trick you. So basically what's happening here is, yeah, this is wrong. And it's because dynamic typing is both good and bad. Dynamic typing means that you know that like you can just set variables to whatever you want, but it also means that if you try and compare two variables that aren't the same, you're going to always get false. So let's fix that by casting X from a string to an int. So now we have this code here, and if we run it now we're going to get 196, and that is because, or we have my favorite number, because we've said, hey, X is now going to be an integer, right? So yeah, this is a very trick question. This was probably like one of the more interesting things just kind of going through these slides was that, yeah, you have to keep that in mind when you're using dynamic typing, is that you could accidentally do that. And this leads to plenty of problems in the real world all the time. So going back to the slides, as we said, this is the correct way of doing it. And talking about conditionals again, we could do, let's say if we have more than one condition, right? We could do something like if this condition, otherwise if this condition, otherwise, and so on and so on and so on for hundreds of if conditions. But that gets really messy. So instead what we're going to do is we're going to use elif. And so elif basically combines this else if into elif. So if one statement, else if another statement, else if another statement, until you reach that else case at the end. And so this is a much more compact way, an easier way to read your code by using this. So now let's look at an example using elif. All right, I forgot to change a link, so we're going to look at the last semester version of it. But so here we go. We have x is equal to what number, and then x is an int, and then we try and test. I might have to go over here. Yeah, we're going to do this. Okay, there we go. So yeah, we're checking if x is an integer, or we're making x an integer, and then we're checking if it's 196. And then if it is, then we're printing we have my favorite number. And then if it's not, then we're checking if it's divisible by 5. And if it is not divisible by 5, then we check we just have x instead. So let's test this out and make sure that works. So if we type in 196, we have my favorite number. If we type in 125, it's going to tell us it's a multiple of 5. And then if we type in, say, 173, it's just going to say we just have 173 instead. So that's how you use elif, and you can chain these as many times as you want. You don't just have to use 2 of them. So let's talk a little bit more about conditionals, and then we're going to get to our first set of polls for the night. So the conditionals that we can use are all kinds of things, but then what we can do, which is really nice, is we can actually use multiple conditions together by chaining them using the and keyword or the or keyword. So I can say if x is greater than 0 and x isn't 5, then it could be 1, 2, 3, 4, but not 5. And that way I can combine them together. So it's really nice to be able to chain those two things together. So let's start with our next poll, right? So here we go. I'm going to start typing up the poll command. All right, so our first question is, Python is a compiled only language. True or false? And so you can start reacting in hashtag pollbot right about now. All right, I'm going to close the bot in another 5-10 seconds here. All right. So it looks like everyone chose false, and that is correct. The Python language is not just compiled. It is compiled, but then it's run through an interpreter at runtime. So that's our first question. Our second question is, to write Pythonic code, less code is usually better. So I'm going to create the poll. All right, I am going to end the poll now. Okay, so our next question is going to be this quick little snippet of code. I know it's pretty small. By the way, the last question is true. Less code is usually better. It's not always better, but usually it is. So this question is a quick little snippet of code, and so I'm going to create the poll. So yeah, this one is a little bit trickier than usual. We'll see what everyone says. All right, I'll give it another 5 seconds here. All right, I'm going to close the poll. Okay, so it looks like about half of you put answer 4, and then another half of you put answer 1. So answer 4 is correct. Remember that Python is not a compiled or is not a compiled only language, so it's not going to check because of dynamic typing whether or not you can add 3 to none. So what's going to happen is it is going to try to add 3 to none, and you're going to just all of a sudden fail. So this is really bad because it means that it's a runtime error, which means if this happens in production code, you aren't going to catch it when you're making it, but instead a user is going to experience a crash, and that's really bad. So this is the one downside with Python, is that you do run into a few of these issues, but hopefully you're writing good Pythonic code so you won't make those kinds of mistakes. So our next question is another question here. So I'm going to create the poll. I don't even remember what question we're on. I think we're on question 4. Oh, my bad. There you go. So yeah, this code has 200, and then it does a bunch of ifs and elifs, and then it has an else state at the end. All right, I'm going to close the poll in another second here. All right, so it looks like 88% of you are wrong. Another dynamic typing trick question. I did take these slides from last semester, and the instructor that wrote these ones wrote a lot of trick questions, and I'm kind of liking it. So this one is a really small thing to catch, and if you notice, the elif for the second elif here is x mod 7. So when you have, as someone pointed out in chat, when you have x mod 7 but no equals equals 0, then x mod 7 in this case is going to return like 2, I think. I can't remember off the top of my head. But it's going to return a non-zero number. And when that happens, because it's not 0, it's going to be considered true. Anything that isn't 0 is typically considered a true statement in almost every programming language. So as a result, it's going to print case 2 just because of the way that it's set up. And so somebody asked if the poll isn't showing up. I currently closed the poll, so that may be a lag-based issue. But I did leave it open for a little bit. The poll's closed when I start talking about the answer. But yeah, so this one is a really tricky question. The elif here is obviously pretty hard to catch if you weren't looking for it. So we're now going to move on and stop talking about our polls, and we are going to move on to our loops. So for loops, we have a couple of different types. We are able to repeatedly run the same code regardless of what type we're using. So that's really useful, and we're going to be covering for loops and while loops. So the difference is a for loop is going to run a set number of times, whereas a while loop will run an infinite number of times. Keep in mind, though, that these loops can actually be transcribed, so you can turn a while loop into a for loop and vice versa. It's just a little bit of math. So here's our first for loop, and we're going to open up the replit here. And so all of the for loop code that I'm going to go over is going to be on that link if you're looking at the lecture slides. So looking at this first for loop, we're going to say for an index I in the range, and then when you put a first number, it's going to say, okay, from the number 0 to 1 minus that input, do something. And so this returns 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 10. So if we comment out the rest of this code right there and hit run, you're going to see now that it says 0 through 9, just like we expected. So now if we go back over to our code, we're going to comment this out, and we're going to talk about our next type here. So going back to the slides, yeah, here's the second one. So in this case, now what we're saying is that we have, for the variable, we are going to go from a range with this lower bound, including this lower bound, and then up to this upper bound, not including it. So this second number doesn't change, but this first number is our starting number. So as you can see, it's going to print out 2 through 9. And there we go, we got 2 through 9. So that is the range with 2 arguments. And so that's sometimes what you'll do, but you'll see a lot of for I in range and then just a number. So now the next thing you can do is you can say range with your start and your end number and an increment number. So this means that it's going to start at 2, and it's going to go to 4, then it's going to go to 6, and then to 8, and then when it goes to 10, it will be out of the range, right? So this 10 is still not going to work, but it's going to try. So if we look at this code now, we're going to get, I think it's 2, 4, 6, 8. Yep, there we go. And so this is really useful if you're trying to do something like only check the even numbers of an array or doing something else. There are a lot of interesting purposes for it, but it is a little bit more of a niche algorithm or way of using the for loop. So now we're going to talk about a different way to do it, and that is using this idea of iterators. So for value in a data structure. So we can define a data structure where we have a way to iterate through it. So we can say for everything in our list or for everything in our graph. And there are different ways to set up those iterators, but in the end, you'll get some sort of way to iterate through it. So in this example, we create x and we say x is equal to 196. And then for every value in x, we're going to print the value. So if we go uncomment that code here, you're going to see we get 196. There we go. Now, that's all well and good, but we can also do something where we do it the normal way. So we can say for I in the range, just like normal, of the length of the array. So this will check how long the array is, and then will give us that length. So in this case, it's 3. So it'll say for I in range, and then the length, and then we can access the items in the array. And I just realized I've been misspeaking. These are actually lists in Python, not arrays. There is a difference, but it's not noticeable for the most part. Okay, so yeah, as I said, we can uncomment this code and it will also give us 196, just like that. So now if I go back, and we're going to mention one other piece of code, and this is one where if you run it, it can work on names too. So we say for name in names, print the name. And so there we go. And we can do stuff like .to uppercase. I think maybe that'll work, hopefully. Nope. I can't remember the command right now, But you can do other stuff like that where you're able to uppercase things and just work with the variable in there. And so it's super nice. So that is sort of the basic level of for loops. Let's talk about while loops, okay? So while loops say while something is true, or while something is true, I then do this. So an example is while this variable x is greater than 50, print x and decrement it by 1. So while x is greater than 50, print out 100, then make it 99, print out 99, make it 98, and so on until you reach x is equal to 50, and then you're going to stop. So if we go to our while loop examples now, you're going to see when we run this, I forgot to turn off the second while loop here. There we go. So when we run this, you're going to see we got 51. I forgot to clear that. There you go. So we got 100 all the way through to 51. So that worked pretty well. Let me see if I can clear that so that makes a little bit clearer sense. Yeah, there we go. We have 100 through 51. So that is sort of a basic way of doing stuff. And so now let's take a look at the next example. So this is what's called an infinite loop. And what's going to happen here is it's going to run forever because it's saying while true. Well, we just said while some statement is true, run this. But because we're just saying while true, it's never going to stop. So in this case, it's just going to keep printing x forever and ever and ever. So if we go back to that example, if I uncomment the code and hit run, it's going to keep printing out. You can see at the bottom, it's doing it super quickly. It's printing out 50 like a million times. And so this is the idea of an infinite loop. And this can be very good or very bad depending on the scenario. Hopefully you never run into it unless you intend to do it. Occasionally you will. Usually it won't be something like this. It'll be something where you accidentally have a variable the wrong way or a conditional the wrong way. And it's always going to run then. So that is while loops. And we can also use break statements. So break statements are the idea that if we're in a loop, but we want to leave it early in case of like a infinite loop or whatever, we can use a break keyword. And so Python reads it and it'll say, okay, whatever loop I'm in, I'm out. And so if we look at this example, 4 character in CS196 and then a bunch of junk afterward. If the character is a space, then print nothing and break. So what this does is it's saying, okay, print every character, and then if the character is a space, run this line here, and then exit out of this loop right here. So let's see that in action. I apparently don't have that for some reason. Did I leave it on? There we go. So we're going to take a look at that. So as you can see, it only prints out CS196 because it prints out each character, and then if the character is a space, it's not going to print out anything. And so that's a super nice way of just like printing out something that you're looking for, but if you need to terminate early, you can always use a break. I know breaks will sometimes divide people just because some people really don't like it, but other people say it's an invaluable tool. So it really depends on personal preference. So let's talk about functions now. I'm also going to close that tab. So functions are the blocks of code that we plan on reusing a lot. So a good example of this is, let's say you're doing something like finding the slope between 2 points, right? Instead of having to write out all the code to do a slope between 2 points and having to copy paste that every time you do that, we can write a function and then make it only 1 line each time we need to do that. So yeah, here we go. So to declare a function in Python, we follow the format def, which is define, a function name, and then arguments inside these parentheses. And then we put a colon, we tab over, and we say the code goes here. So in Python, you don't need to specify the return types for your functions, and you can just return. We'll talk about that in a minute. But the point here is that a function can take in some arguments, run some code on those arguments, and then pass stuff back out so that way you can reuse code that you have to do multiple times. So here's an example, and I'm going to open up this example in Replit. So in this example, we have a greeting, that takes in a name and a time of day. And so we say if the time of day is M, meaning morning, print good morning, and then it takes your name. So in this case, my name is Matt, and if we run it with argument M, you'll see good morning, Matt. And so we can check elif, it's afternoon, or good evening, whichever greeting we want. Otherwise, if I put in like spacebar, you're just going to get hello, Matt, right? So the reason we're doing this is because let's say we want to greet Eustace and then the rest of the students, right? Or all of the students. So there we go. And so instead of having to write all of this code 3 times and replacing all the variables, now I can write 3 lines and it's going to do the same thing each time for each of these variables. And so combined with for loops, this can be really powerful. So you can do for name in, and then we'll just define a variable here, Matt, Eustace, and CS196 students. And then inside here, we're going to greet, and we're going to put in the name, and we're going to say, because it's evening, we're going to put an E. And there you go. So now you see the exact same code. And so now we've gone from however many lines that is, about 12 lines per time we're greeting, to now 2 lines for all of our greetings, as well as the definition. So this has greatly reduced our code, and it makes it much easier to read as well. So that's the idea behind functions. And so let's talk a little bit more in depth, right? When we take a look at that code, we have arguments. So we say define the greeting function, where we have name and time of day. And so it takes in these variables, and then we can use them however we want. And so in this example, we have greet Rohan because that was the previous instructor, and then in the evening because 196 is presented at 7 p.m. So it's going to say greet and then whoever you put in. So in this case, it could be greet Matt, and then with the evening argument. So those arguments are passed in and are a way for us to evaluate things. And so what we can do is we can actually do, so I'm going to make a small change here because I apparently forgot how to lowercase things in Python. But now what I can do is I can say name 0, and hopefully, yeah, there we go. So you'll see it says good morning to Matt, good evening to Eustace, and hello to CS196 students. And that's because it just so happens Matt is morning, and so the first letter of my name is M, which corresponds there. And then Eustace has E for evening, and then CS196 has C, so it just kind of gets the generic hello. So you can do a lot of cool different things there. So now for returning, what we can do is we can change that function to give us a string later on. And the reason we would do that is because we want code to be given back to us once the function is done. And if we want to manually leave the function and give something back, we can use return. So let's take a look at a couple examples of that. Yeah, here we go. So here's an example of a sign function. So let me open up that code. Yeah, so we say define a sign function that takes in an argument x, and then if x is greater than 0, return 1. If it's equal to 0, return 0. If it's less than 0, or if otherwise, because we know we've covered all the other possible cases, return -1. And so now if we run test on 5, -5, and 0, when we print those out, we're going to get 1, -1, and 0 because it brings it down to that last value. So this is really useful because that way we don't have to deal with anything crazy in terms of like we don't have to deal with trying to figure out those things by ourselves, and we can actually get good data out of the functions. So here's another example, and this is where it gets more complicated, right? So if we open up this example, it's going to get the 2 largest factors of a number. So if you try and put in 0, it's not going to work, and it's going to return none because we don't know the 2 largest factors. Otherwise, we're going to set the 2 largest factors to x and 1 in case it's a prime number, and then we're going to iterate backwards until we can find the 2 largest factors. And So here's how that works. It's very slow because that's just how numbers work, and this specific algorithm is very time consuming. But if we run it, you're going to see you're going to get a couple of different examples. So you're going to get 5 and 15 for when we put in 15, because you're going to get 15 and 1 and then 5 and 3. So 5 and 15 are the two largest. Then 50 and 100 is going to be the next possible combination. In that case, it's 2 times 50 and 100 times 1. And then you get nice try, don't break me. And you'll see there it returns none and none because we are returning that in the event that someone tries to input 0. So that is sort of more like complicated example where you're using none. You have to potentially break out of a function if you found something that works, and then you're returning multiple things at once. So yeah, that's a really good example of like a more complex function. And let's talk about lists. We kind of talked about it a little bit already because it's really hard to avoid lists when you're talking about other stuff. But lists are a collection that's ordered and changeable. So what's really nice about this is that you can put duplicate values in, you can order them in a certain way, but then you can change the order. And it allows you to do a lot of cool different things. And so what the difference between a list and an array is that a list is resizable. And you heard me talking about it as if it's an array, just because that's what I'm more used to. But in this case, Python is lists because you can resize the list at any point. So not sure what that link is for, but let's take a look. Yeah, so this is just kind of an example about lists that you can read more into, but we're going to kind of talk about it a little bit. So in Python, the types of elements don't need to be the same for lists, which is really cool. So you can say a list of, say, Matt, but then a number, and then 196, and you can just throw all kinds of different things inside of a list. So it's a really cool way to store a bunch of different data. And so we can also use lists to store multiple variables, or, well, this is the main purpose of a list, is basically storing multiple things in one variable. So if we go to the list code, let me open up that. You're going to see here that we have first off, we say we're declaring a list by just putting those brackets. And so what these brackets do is they create a list and it's empty. So that's all that is. But then we're going to put some variables in it. So we're going to say, in this case, we want CS196 as strings all in this variable. So all of these are separate, but we're going to be using them to put things together. So now what we can do is we can access elements by putting these square brackets around them, right? And so if I do that, let's uncomment that code. You're going to see we get and a bunch of other stuff because I didn't comment or uncomment things properly. Give me 1 second to do that. Okay, there we go. So now if we take a look at this code, right, and I rerun it, you're going to get C and 9 because we went from 0 and 3. However, if we try and do something else, like this code down here, where we use a variable that is out of our range, say -1 or 10, it's going to break. So as you can see here, it's not really sure what's happening, and it just breaks. So in this case, we say -1 and it doesn't work. So instead, what we want to do is make sure that we are staying within the bounds of the range. So now let's talk about the next part of lists, which is how do we stay within that range? And that is by getting the length of that list. So if I uncomment this code, you're going to see that the length of the list is 5 because that's how many that we have. Yeah, so in this case, you have 5 items in the list because you have CS196, 5 items. The next part, what we're going to do is we're going to slice. And so slicing is a really cool thing. And I'm realizing we are running out of time very quickly, so I'm going to try and speed through this. But slicing is where you can take parts of an array, or sorry, parts of a list, and only use those. So in this case, we're saying take X from indices 2 to 5 and give us those back. So in this case, we get 1, 9, and 6, and we don't have to worry about anything else. So now in the next case, we have printing, and we can use different types of slices. So we can say print X from indices 2 to the end, print X from 0 to 2, And then we can also do print from the start to. And so these are all kinds of different ways to print, and they all work. It's just kind of a choice. So now lists can also take strings, but interestingly, strings will basically have strings are basically a list of characters. And so the way it works is just like we talked about up here, it's CS196. And if I did x is equal to CS196 and rerun this code, you're going to see it's actually going to work just fine. There we go. See, we just got C9, and if I comment that line out, we're also going to get C9. So strings in Python are very similar to lists in Python. And so yeah, there's a good example of that. So useful functions with lists include appending, which puts the last item at the end of the list, inserting, which allows you to insert at a certain point in the list, sorting, which will sort depending on how it works. It really just depends. In this case, you're going to, let me see here. Yeah, so what sort will do is it's going to go through the array and it'll find the first thing, or the list, and it'll find the first thing that matches this case right here, and then it'll remove it. And insert, you can just insert somewhere else. So you can also pop, reverse, and sort. So pop will just take the first thing out of the list. Reverse is going to obviously reverse the list. And then sort is going to sort the list from front to back. So exception handling, I don't think we're going to have time for. I do want to get to the second set of questions. So let's see if we can skip those for now, and hopefully Eustace can find time for that. Yeah, okay. Do we have, yeah, so here we go. So I'm going to launch a poll. So yeah, take another 15, 30 seconds there. All right, I'm going to close the poll after what was definitely not 15 or 30 seconds, but that's fine. So it looks like everyone answered 1, and that is correct. So we say while x is not equal to 186, print x, and then start over. X is never changing, so it's always going to be 200. Good job on that. So how many arguments does this function take? So I'm going to create a new poll. All right, I'm going to close the poll now. All right, so it looks like 100% of you got it right again. The arguments is going to be 3 because you have instructors, staff, and students. Perfect. So here is our final sort of tricky question. I'm going to create this one. So this one is definitely a trick question. This one's probably going to be the hardest of the night. To all of you putting 4 blindly, I would advise you to potentially rethink your answer. All right, so it looks like everyone has kind of settled into their answers, so I'm gonna close the poll. So there were 34% of you that stuck with 4, and 4 was correct. I specifically said for those of you putting 4 blindly, um, just to see if anyone was listening. And so, yeah, the answer here is 4 because you're saying you're going to have C there, and then you're going to skip 3. So 1, 2, and then you're going to get this third. So CS, then 1, 2, 3, you get 1, then 1, 2, 3, 9, 1, 2, 3, 6. And so that's why you get CS196. So yeah, at this point, I'm going to stick around for questions. I did kind of go over on time. Hopefully, we'll find time for exceptions. I might also just record a quick video on that just to try and recap that. Otherwise, it'll be in the next lecture. And worst case scenario, if it comes up on the homework, which I think it does, just take a look at the slides in the meantime, and those will at least be pretty helpful. Also, for those of you worrying about changing your answer, it doesn't really matter as long as you participated. I was just throwing off the people who seem to be blindly guessing based off of our poll bot. So actually, if you put a second answer in the poll, it will overwrite your original one. I'm pretty sure it's in Python. You're going to have to ask Tim. He's our resident bot builder. Yeah, it looks like all of the Python related questions are done for the day. So I'm going to end the stream. Thank you so much for coming, and I guess I'll see you in a few weeks.